Bentornati e ben connessi nuovamente al nostro canale YouTube GIScience TV. Come promesso dalla scorsa settimana, dal primo tutorial che abbiamo pubblicato all'interno di questa playlist, il nostro team vuole condividere con tutti quanti voi i seminari, i workshop e gli insegnamenti svolti all'interno del festival Drones for Good 2020, il festival che abbiamo creato per la divulgazione delle nuove tecnologie dell'informazione geografica e ovviamente dell'utilizzo dei droni in ambito ambientale e territoriale. Quest'oggi ci dedichiamo al secondo seminario di questo festival tenuto dal professor Michael Hodgson della University of South Carolina, con cui ormai il nostro team collabora da anni. Il titolo del seminario, l'uso dei paesaggi in scala per i rilievi indoor con droni nella didattica universitaria della geografia degli Stati Uniti, vuole indagare proprio il grande tema dei rilievi indoor, questa volta costruendo paesaggi in scala attraverso l'utilizzo di droni low cost. Il seminario è in lingua inglese, ma non perdetevi questi fantastici contenuti. Buona giornata a tutti quanti voi.
Passiamo la parola al professor Michael Hodgson. Devo dire che l'intervento sarà in lingua inglese, per cui chiediamo un po' di flessibilità, insomma, per non diciamo quelli che hanno dimestichezza e si sentono comodi con la lingua. Lo ringrazio soprattutto per l'ora di collegamento. Lui si sta collegando dalla South Carolina, sono le 5:27 am. Thank you, Michael. If you're ready, you can start with your presentation. We are going to talk about l'uso di paesaggi in scala per rilievi indoor con droni nella didattica universitaria della geografia negli Stati Uniti. Thank you, Michael. You can start.
Thank you, Eugenio, for the kind introduction. It is a little early here in the Stati Uniti, but I want to share with you some research, didactical related research that both myself and Sylvia Piovani started a couple of years ago. It involves teaching drone related concepts and flight operations. And so most of you who are familiar with trying to teach drone-related activities in a class know there's two main objectives. One is to teach the fundamental principles of mapping, collecting imagery, photogrammetry, planning for operations, and then processing the data. And the second part of that is the actual flight operations. And what we're going to share with you today is to separate the two into the theoretical photogrammetric part of it in the classroom, including what we would regard as simulating the actual collection of imagery in the classroom rather than outdoors. And we wanted to do that because of the logistical challenges. Now, I will say at the very end of this, we still have flight operations outside, but we limit the number of activities that we do outside. The problem with teaching the actual flight operations on an urban campus, which is the same as the University of Padova, is that we're near a major airport, okay? And we're also near the state capitol, and there are lots of students and lots of people continually in the landscape. And so for us to be able to schedule flight operations requires us to get FAA authorization, which we can do, to find a practice field without students and other people, and then hope the weather is good, okay? And so teaching a class like this each spring semester results into many, many challenges. And so what we're going to do is to separate most of the learning experiences into the indoor classroom. And what we're going to do is to use a scaled landscape, okay? I don't know for the first group to do this with drones. I think maybe Massimo De Marchi, Eugenio, and you guys did this with the large facility of the Venice Lagoon. We started this a couple of years ago with the concept of a scaled city, okay? And again, after having gone through one exercise of scheduling an outdoor flight operations, I realized most of the learning could be done inside the classroom. So there's many problems with doing the actual flight operations with a large number of students outside. One of which is the weather, and we have orographic precipitation that occurs almost every afternoon in the springtime. And then there's the winds associated with controlling the drone. There's obviously safety and security concerns. We cannot fly over crowds of people on our urban campus. You have lots of people. And then we have a lot of legal issues to deal with. The certificate that's required to fly by the federal government, and some states also require, and then the drone registration, the insurance that's required. And then the issues with privacy that we have, similar to those that you have in Europe. Okay. So we're gonna create a scaled landscape indoors and have the students practice collecting imagery inside. Okay. So how do we do that? Well, it's actually quite simple, and you could use most of the materials that come out of your kitchen. Okay. In fact, these are cereal boxes. They're cups that you might drink, coffee or other liquids in it. So food packaging and glue, some newspaper, and some paint, and suddenly you have scale landscape features such as the trees, the churches, and the small building. We're trying to emulate the same kind of landscape features and the problems that you would see in the real world. Okay, for example, this is a coal tipple in Lynch, Kentucky. Okay, it's a very 200 feet tall coal tipple with even taller smokestack, and so we replicate that using a simple drinking cup. Okay, and this is the completed landscape city that we put together for the students to collect photography from and then to process it into models. And you can see that some of the features have tall, some of them are small, and a problem that you probably have discovered when working with imagery is we have some smooth surfaces that create significant issues with trying to do the surface structure from motion. So we have a lot of theoretical issues that we cover in the class: ground control and the scaling, camera viewing angles, such as oblique versus nadir, the spatial resolution, the fundamental photogrammetric principles, and then the 2D versus 3D mapping and modeling. And in my class, focused mostly on the mapping and the modeling part of it. And because the students in the courses typically have a fundamental aerial photography or photogrammetry class, I have to reteach them the concepts behind structure for motion. And then we talk about the different issues with creating 3D models. This is the city in a seminar room that we reserve for a month during the semester. And the first thing that we do is to create a coordinate system. And this is a great learning experience for the students because they now understand that they don't have to use a global coordinate system like latitude and longitude, but they can use a local coordinate system. And we place ground control points on the landscape at different locations. And also we have some other validation points that are on top of buildings and on the landscape features. The way that we measure this precisely inside the classroom is to use a surveying instrument called a total station. Okay? And by doing it, by conducting the exercise in the classroom, the scale city, students learn how to scale their three-dimensional model. They also learn how to evaluate the planimetric and the orthometric accuracy of their model. Okay? So we bring a total station inside the classroom, and we measure the location of the ground control points and our validation points. And you might think one of the more fundamental problems is how to take a reflector like a prism on a prism pole and hold it on top of the landscape. And the solution for that is to use a reflectorless total station that doesn't require a prism. Okay? And so this is actually in Italian. total station. And so this is the laser reflecting off this is a surveying grade target. And we have our ground control points that we position. And students can practice with not only the measurement of these using a total station, but they can also practice with how many ground control points they actually need to adequately reconstruct the orthomosaic and the three-dimensional model. Okay. We go over the fundamental photogrammetry principles so that they understand what a planimetric map is and what relief displacement is for surface features that are above the ground surface, how they would appear on an image, such as an image from a Droni. And we're trying to teach them concepts of measuring in 3 dimensions. And they do this using software like Pix4D later in the semester with real data. This is the actual coal tipple in Lynch, Kentucky from drone imagery. But they also do this with the scale city. Okay? And so here's our part of our landscape from the scale city. And they practice with using different altitudes of their camera. They work through the issues of how much image overlap they need to adequately construct the different sides of a 3-dimensional figure, how to deal with occlusion problems from one feature occluding another feature, the issues of nadir versus oblique photography, and as I mentioned before, the number of ground control points that they need. Okay. So for students that have had fundamental photogrammetry, they know that they can reconstruct a 3-dimensional model if they have image overlap, at least 50%. Okay, that's the classical way, one stereo pair. But structure for motion is a little bit different principle, and you need at least 3 images, preferably 5 images, covering every single point on the landscape. And they quickly learn this when they reconstruct the 3-dimensional model. Okay. Now, the students use their own cell phone and their camera, and they deal with the problems of holding the camera at a constant altitude as they move over the city. They want to hold the camera level, and I let them use a simple bubble level on the camera, but they realize this is very, very difficult to do, which is a good learning experience because then I get to talk about the concept of a gimbal on a drone and how it holds the camera completely nadir or at a specific vertical angle. The big advantage in having the scale city is that the students can come back to the city and collect photography again and again and again, as many times as they want to adjust the collection parameters and see if that does better. I have them use some free and inexpensive software called Microsoft Ice to reconstruct in an automated fashion a composite map of all the images that they've collected. And immediately they see that there's still relief displacement after the mosaic has been put together. And so this takes us into why you would want to build a 3-dimensional model so that you can actually create a orthomosaic so that all of the features have their correct planimetric position. Okay. And then in the final parts of the class, we talk about measuring heights and volumes. And again, volumes of the cylinders, heights of the cylinders, the planimetric distances on the landscape. They can do that because now they have a digital surface model as well as an orthomosaic, and so that they can actually treat it as a 3-dimensional landscape. They quickly learn what a 3D point cloud is and the apparent holes in a 3D point cloud. And then they understand what a triangular mesh is, which is what you and I would call a simple interpolation, but in a 3-dimensional sense rather than a 2-dimensional sense. Okay. Now, having used a scale landscape to let the students focus most on image collection and processing characteristics, then we would take them outside or indoors and actually have them fly a drone for some flight experience. But in the flight experience, we have the students focus on the flight and not on the collection issues involved, so that they can more accurately and more safety control the drone. Each student that walks into my office hours, I have them fly a little SIMA drone inside my office, which they quickly learn to master. And then in a more organized fashion, we take all the students down to a large room in our department, and they fly a visual drone, which does not have a GNSS. Okay? And then finally, we take them outside and have them fly one of the Phantom 4 drones that we have. Okay? So this is a couple of the students flying the visual indoors, and yes, they crash into walls and everything else. And so they quickly learned that a GNSS is extremely important. Okay? And then later we take them outside to a different landscape. Okay? Students also need experience collecting ground control points. Here's we're teaching them how to use a GNSS receiver and a total station. And then finally, we actually have the students collect their own imagery and look at it so that they understand the optical resolution in the imagery and how much resolution they need for the kind of targets, such as even seeing the ground control points. So in summary, the students focus on the image collection principles in the classroom with the scale city instead of flying. Okay? They can practice many times, many more times than having 1 or 2 times outside. Weather is never an issue inside. Okay? The legal issues are non-existent. Okay? And each student can practice as many times as they want to. So I want to end the discussion now and thank you for your attention.